Alrighty guys, this is page 5 of your Unit 6 review. This is number 23 to 26. Number 23, the direction for 23 to 25 says assume continuous growth for the following. So you have to use the principal times base of e raised to the r times t, rate times time. Alright, so let's take a look. Here's your principal. A $25,000 car depreciates. So that means you're going to go down every year. When will the car be worth less than $5,000? There's your final balance. So here I have set up your A is equal to 25,000 times e raised to the negative 0.09t. Okay? You can do this by calculator and finding the intersection, or you guys know a little bit about logs now from radioactive decay. I would do it this way. So first of all, I would divide both sides by 25,000. What you do to one, you do to the other, okay? So you have 5,000 divided by 25,000. That leaves you 0.2 equals e raised to the 0.09t. Now the question says when. You're looking for t, okay? Go back a little bit. B to the x is equal to y. Inverse of that is log base b of y is equal to x. Do you see how this one looks like this? Let's use logarithm to try to solve. Okay? So, here we go. E to that, so e to 0.2, I'm going to take the log of e, is equal to negative 0.09t. Do you see that right there? Log base e is the same thing as natural log, negative 0.09t. Now, notice your t is no longer in the exponential position. Now you can solve for t. So divide both sides by negative 0.09. What you do to one, you do to the other. And then on your calculator, you can just solve. Here's your natural log button right here. See that? So I'm going to type natural log 0.2. Put parentheses around your 0.2 because that's the only one that's being using natural log. Divided by negative 0.09. Okay? So how long is it going to take for that car to be worth $5,000? 17.88 years. Because it says every year up here. There you go. So almost 18 years. Okay? Number 24. Now, if you had done it the other way, you would plug this one into Y1, this one into Y2, and you can go find your intersection. That will be fine. Just make sure your window's correct. But now that you know how to do this, I would do it this way instead. 24. The population of koalas in Australia is increasing by 3%. So this is a plus 0.03. If there are currently 1,000 koalas, okay, so this is your beginning, how many will there be in March of 2020? Well, how many years is that? Okay, just assume that this is March. So from here to 2020, that's 3 years. So your t is equal to 3. So you have A is equal to 10,000. Try not to write with a comma, because when you do, it sometimes looks like a decimal. Increasing at 0.03 for 3 years. Okay, 2017, 18, 19, and 20. So you're starting in 2017. So 18, 19, and 20. That's 3 years. Ooh, that looked creepy. Okay, now you can just kind of solve. You can just type it in like you see it. So you're going to take 10,000. Here's your E right here. Okay, there's your E. Or you can use this one down here, your choice. I'm going to use this one here, second E, raised to 0.03 times 3 years. And so there I have my equation. So how many koala bears are we going to have? Well, A is equal to 10,941.74. Now guys, can you seriously have a 0.74 koalas? No, even if their arm is cut off or something, it is still a koala, okay? So the answer is 10,941 koala bears, because they don't have enough for another one. So make sure you round correctly. All right. 25. Russellville population is currently 28,000. Assuming we are going at a rate of 2% each year, how long will it take until Russellville has 50,000? So here's your A. 28,000 is current. There's your P. All right. So you got 50,000 equals 28,000 E at a rate of 0.02 increasing times your T, because you don't know what this is. Let me erase this and make it a little bit better. Okay, there's your T, there's your A. All right, now you can solve it two ways. You can graph, or I'm going to use logarithm because I think it's easier to do logs. So I'm going to divide both sides by 28,000. What you do to one side, you do to the other side. Okay? So 50,000, 1, 2, 3, divided by 28,000. That gives you 1.7857. Okay? And if you want to write the rest of the numbers, you can. Equals E raised to the 0.02t. Now notice I'm solving for how long, which is your t. It's in the exponential position. So I'm going to go into natural log because it's a base e. Okay? But if you're stuck, go ahead and write it like this first. Log base e of 1.7857 is equal to 0.02t. You can write it like that. Log base e is the same thing as natural log. And now you can divide by 0.02. What you do to one side, you do to the other side. So those guys cancel, and this is how you type it in. So you type in natural log 1.7857, okay, divided by 0.02. So it's going to take 28.99 years. Let's go ahead and round that to 29 years. Okay, don't forget your unit, very important. So this is 29 years. There you go. All right. Now, if you really wanted to be accurate, what you could have done is you could have taken natural log and you could have said 50,000 divided by 28,000. There you go. Divided by 0.02. See how the numbers are very close to each other. Not too far apart. So I rounded and the other ones I did not. All right. Number 26. We're now talking about radioactive decay. And since it's continuous, you will always use this formula here, okay? Carbon doesn't all of a sudden say, hey, I think I'm going to start decaying for 6 months. It doesn't work that way. It is continuously decaying. All right, find the decay rate. So I'm looking for the rate for carbon-14. Use that to help determine the old fossil that it contains 18% of its original carbon. So let's go ahead and start our equation. You have 18% left. A percent is always out of 100. We don't know what the rate is, and we don't know what the time is. So this is our original equation, okay? Now we know something. We know the half-life of carbon is 5,730. So half-life means what? 50% out of 100 is equal to E raised to the R times a half-life. How long is that half-life? 5,730, okay? Notice what you have left. You have an R left that you need to go solve for. So let's go ahead and solve. First of all, divide by 100. That gives you 0.5 is equal to E R raised to the 5730 times that. All right, notice it's a base E. Base E is the same thing as natural log of 0.5. Remember those arrows. Is equal to R times 5730. I'm looking for the rate. Now what do? Well, I'm solving for R, so I'm going to divide by 5,730. What you do to one side, you do to the other side. This is going to give you your rate. Okay? So you have natural log 0.5 divided by 5730. And that is going to be negative 1.097 times 10 to the negative 4. That's what that E means. Now you can write it like that, or you can put 1.2097 and move it 4 decimal places. 1, 2, 3, 4. Either way, these are exactly the same. Okay? I'm just going to keep it in scientific notation. All right. Now that you know what the rate is, now you can plug it back in. So you have 18 equals 100, because that's how much percent you have left. E raised to the negative 1.2 times 10 to the negative 4 times your t. Now you can know how old this fossil is, okay? Alrighty, same thing, 8 divided by 100. So you got 0.18 is equal to negative 1.2 times 10 to the negative 4t. So sorry, I should have had an E here. Okay, let me rewrite it. I left something off. 0.18 is equal to E raised to the negative 1.2 times 10 to the negative 4t. Alright, now rewrite this as a natural log. Natural log of 0.18 is equal to negative 1.2 times 10 to the negative 4t. Okay, now how do you solve for t? You divide both sides by negative 1.2 times 10 to the negative 4. What you do to one side, you do to the other side. So t is equal to, so let me show you how to type this in correctly into your calculator. Okay, so you're going to take natural log 0.18, see that right there, divided by negative 1.2, here's your EE button right here, alright, that's times 10, right there, let me see if you can, there you go, times 10 to the negative 4, and that's how you type that in, just like that. So, how old is that fossil? 14,289.99. Okay, you can round it to the year, or you can put 0.99. All right, so that fossil is 14,289.99, or you can say 14,290 years old. Right there. Okay. Well, good luck, guys. There'll be a radioactive decay problem on there. Remember, you have to go find the R first by using what you know and going on to the other one, okay? Now, let me show you how to do this one, say number 25, using a calculator. All right, so here we go. You would go to y equal. First, number 25, you would put 50,000. Second one, you would put 28,000. Okay. Second, E raised to the 0.02x. See how I just typed that? Now you're going to actually have to change your window. You want to know how long something is. So I'm going to leave that at -1. Oh, let's make this 35. Moving it at 5. Your y minimum, you can start at 0. And your biggest number is 50,000, so let's go ahead at 70,000. Okay? And I'm going to change my scale to 10,000 because I don't like a bunch of little marks. And there you have your intersection. Right there. Okay. Second count, you can go to intersect, so you can do it this way. There's the first curve, marked it there. Second curve is to the right of the intersection, anywhere to the right, enter. So at 50,000, it's 28.99. Two different methods. If you like the calculator and do it this way, or you can solve knowing some information that you're able to go from logarithms to exponential and their inverses. All right, good luck on your test. Bye. Oh, shout out to my 8th period. You guys are awesome.